Chapter 1.5, combinations of functions. So in this section, we're going to review adding, subtracting, multiplying, dividing functions, finding compositions of one function with another function. So this is something new, and then using them to solve and model real life problems. So the first definition is sum, difference, product, and quotient of functions. So let f and g be two functions with overlapping domains. Then for all x common to both domains, the sum, difference, product, and quotient of f and g are defined as followed. So f plus g of x means to add f of x plus g of x. F minus g of x is equal to f of x minus g of x. So here, something to put a note. Order matters. Product f g of x means f of x times g of x. Quotient f over g of x is equal to f of x divided by g of x, where g of x cannot be 0. So highlight this because this is important, because we can't divide by 0. And then here also order matters. All right, so example 1, given f of x is 2x plus 1 and g of x is x squared plus 2x minus 1, find f plus g of x and then evaluate the sum when x equals 2 and then state the domain. Just say state the domain of f plus g of x. So f plus g of x is just equal to f of x plus g of x. So f of x, they told us, was 2x plus 1. G of x is x squared plus 2x minus 1. So all you have to do is just simplify by combining like terms. So x squared plus 4x, 1 minus 1 is 0. So this is f plus g of x. So f plus g of 2 means that in this result, wherever you see an x, we're going to change it to a 2. So that means that we're going to do 2 squared plus 4 times 2, which is the same thing as 4 plus 8, which is 12. Then state the domain. For this function right here, we have to look back at the original function. So this is a linear function, all real numbers. The domain of this guy, it's a quadratic, all real numbers. So if we add these two functions together, all real numbers plus all real numbers, the result is also going to be all real numbers. So the domain of f plus g of x is negative infinity to infinity. 2, same two functions, evaluate, find first f minus g of x, and then evaluate when x equals 2, and then state the domain. So order matters. So f minus g of x, f comes first. So that means they want to do f of x minus g of x. So it's going to be equal to 2x plus 1 minus x squared plus 2x minus 1. So I'm going to distribute this negative to everything. Excuse me. Because of the subtraction, I'm going to distribute this negative to everything. So this is going to become 2x plus 1 minus x squared minus 2x plus 1, and then combine like terms. I notice that the 2x's are going to cancel. So I'm going to be left with, in standard form, negative x squared plus 2. So then evaluate when x is equal to 2. So f minus g of 2 means that in our answer, I'm going to change the x to a 2, replace the x with a 2. So it's going to be negative parentheses 2 squared plus 2, which is equal to negative 4 plus 2, which is negative 2. Then the domain. So again, Same two functions, so all real numbers, all real numbers. So their domains, when they overlap, all real numbers and all real numbers means that there really is no restriction. So the result of this means that the domain of f minus g of x is going to be negative infinity to infinity. Okay, product. Given f of x is x squared, g of x is x minus 3, find f g of x, and then evaluate when x equals 4, and then state the domain. So f g of x is equal to just f of x times g of x. So that's going to be x squared times x minus 3. So I'm just going to distribute. Sorry about that. So distribute the x squared to both terms, and you should get x cubed minus 3x squared. So this is the product. So then to find when x equals 4, we're going to plug in 4. So f g of 4, we're going to plug in the 4 wherever we see an x. So this will equal parentheses 4 cubed minus 3 times 4 squared. 4 cubed is 64 minus 3 times 16, because 4 squared 16. So it's going to be 64 minus 48, which is 16. Domain. So the domain of this depends, even though this looks cubic, it's tempting to say that it's all real numbers. But if we go back, x squared, just verify all real numbers. This is linear, all real numbers. So when we multiply them and we get this as a result, this is also all real numbers. So the domain of f g of x is going to be negative infinity to infinity. All right, quotients. So division now. Given f of x is equal to the square root of x and g of x is the square root of 4 minus x squared, find f over g of x and then state the domain. So this time it's not asking us to evaluate. We could if it asked us to, but we don't have to worry about it if they're not asking us to. So for something like this, order matters. So f over g of x just means f of x divided by g of x. So f of x goes on top, so square root of x over the square root of 4 minus x squared. Now, if we really wanted to, we could clean this up and simplify it even more, but since that's not really what they're wanting us to do, the main concern they want us to do is to find the domain. So for this guy, we have to kind of pay attention to both functions here. So the domain, so let me put a box around this. This is the answer for the function. For the domain of square root of x, okay, we've done this one a couple times. Square root of x, the domain is 0 to infinity, because we can take the square root of 0 and then anything positive. The domain of the bottom, okay, if you weren't sure what this was, you can plug this into a calculator, a graphing calculator. Okay, this is the graph of a semicircle. So also what we could think about is 4 minus x squared. We want that greater than or equal to 0. And if we solve this, negative x squared is greater than or equal to negative 4. X squared is less than or equal to positive 4. If we square root both sides, you're going to get x is less than or equal to 2, or x is greater than or equal to negative 2, because the negative, remember, plus or minus, the negative is actually going to cause this sign to flip. So x is less than or equal to 2, and x is greater than or equal to negative 2. So it's in between those two numbers. So the domain of these two functions, of this function, is negative 2 to 2. Okay. Now, the overlap of these, okay, we can't plug in -2 into this guy. So anything that's less than 0, because this function, it's 0 or more, anything that's less than 0 won't work for the top function. So if it doesn't work for the top function, it's not going to work for the division of the two functions. So basically, I can't use anything that's between -2 and 0. It has to start at 0, but I can't also use anything bigger than 2 for the bottom function. So even though the top function is 0 to infinity, I can only use basically the overlap of these two, which means that if I'm looking at this on a number line, one of them is 0 to infinity. One of them is 0 to infinity, and the other one is between -2 and 2. So basically where they overlap is this part, if you guys can see that. So another thing we have to be careful about, though, is the bottom actually can't be 0. So even though I can use 2 here, I technically can't, because 2 squared is 4. 4 minus 4 is 0. Square root of 0 is 0. That would mean the bottom 0. So I should be making this a parentheses, which means that this guy is actually an open circle. Which means that the true domain is bracket 0 all the way to 2 with the parentheses. So the domain of f over g of x is bracket 0 to 2 with the parentheses. All right, composition of functions. So this is very important for calculus. You do this thing called the chain rule when you get to calculus, but basically this is like an inside-outside function. Composition of functions is denoted as, you guys need to know this, f with the open circle g, but we don't say f circle g, or fog, it looks like the word fog, f composed with g. So f composed with g is how you pronounce this. So the composition of the function f with the function g is written as f composed with g of x, which is the same thing as f of g of x. So g of x is the inner function in this case, and f of x is the outer function. The domain of the composition is a set of all x in the domain of g, such that g of x is also in the domain of f. So if it's the x's that are in the domain of g, where g of x is also in the domain of f. So it'll be a little bit easier to tell when we want to, when we actually do a problem. So example. So I'm actually going to put a little sticky note on this guy for right now. So find f composed with g of x and g composed with f of x, and if possible, g composed of f of 3. So so for the first part, f composed with g of x by definition is f of g of x. So what that means is we're going to take the f of x function, and wherever you see an x, we're going to replace it with the g of x function. So this is kind of like our input. So f of x is x squared. So wherever there's an x, I'm going to put a parentheses, and then I'm going to replace the x with the entire function of g of x. So this guy is going to go there. So it's going to be x plus 1 squared, which we simplify that, x plus 1 times x plus 1 is just x squared plus 2x plus 1. G composed of f of x means G of f of x. So what that means is wherever you see an x in G of x, wherever you see an x in G of x, I'm going to replace it with f of x. So now this guy is going to go there. So this is going to equal x squared minus 1, which is just x squared minus 1. So then, if possible, G composed of f of 3. So the domain of this and the domain of this is all real numbers. So we don't really have to worry about the if possible part because we can. So G composed of f of 3 means that we're going to take the G composed of x, with G composed of f of x, which is this guy, and replace the x with a positive 3. So G composed with f of 3 is going to be equal to, 3 squared minus 1, which is 8. Find f composed of G of x, and these are our functions now. F of x is equal to the square root of x, and G of x is equal to x minus 1, but this time, sorry guys, I don't know what's wrong with my computer, it keeps doing this. Okay, sorry about that. So for part B, this time f of x is the square root of x, and G of x is x minus 1, but this time they give us little domain restrictions. So we have to pay attention to that when we actually do the composition, but we're going to first find f composed of G of x. So f composed of G of x means f of G of x. So wherever we see an x in G of x, whenever we see an x in f of x, we're going to replace it with the entire G of x function. So f composed of G of x is the square root of G of x is going to replace x in the function. So it's going to be the square root of just x minus 1. So then f composed of G of 2 means that I'm going to plug 2 in for x in this function. So it's going to be the square root of 2 minus 1, which is the square root of 1, which is 1. F composed of G of 0 is going to be the square root of 0 minus 1, which is the square root of negative 1. Now, I know that in previous classes, you guys have learned that this is I, but we're working in the real numbers right now. So the square root of negative 1 does not exist. So this is not possible because it doesn't exist. Okay. Find f composed of G, G composed of f, and if possible, f composed of G of 0. So f composed of G of x is the same thing as f of G of x, which is going to be f of G of x is 5 minus x. So wherever we see an x and f of x, we're going to replace it with 5 minus x. So it's going to be 3 times 5 minus x plus 5. Distributing, you get 15 minus 3x plus 5, which is negative 3x plus 20. G composed of f of x is the same thing as G of f of x, which is going to be G of f of x is 3x plus 5. So what it means is wherever you see an x in G of x, I'm going to replace it with 3x plus 5. So it's going to be equal to 5 minus parentheses 3x plus 5, which is going to be 5 minus 3x minus 5, where these cancel. So we're going to just get negative 3x. So then it's asking us to, if possible, find f composed of G of 0. Well, these are both linear, so there's really no domain restriction. unlike the last one where it did give us a domain restriction and we had a square root, these are both linear. So we should be able to plug in whatever we want. So f composed of g of 0 is going to be taking this function and we're going to replace the x with 0. So it's just going to be -3 times 0 plus 20. Anything times 0 is 0. So 0 plus 20 is 20. Okay, given f of x is x plus 2 and g of x is 4 minus x squared, evaluate f composed of g of x, g composed of f of x, when x equals 0 and when x equals 1. Okay, so for A, f composed of g of x is f of g of x, which is going to be f of g of x is 4 minus x squared. So that means that wherever I see an x and f of x, I'm going to replace it with 4 minus x squared. So it's going to be parentheses 4 minus x squared plus 2, because I'm replacing the x with the entire g of x function. Combining like terms, you're going to get 6 minus x squared. So then it wants us to figure this out when x is 0 and when x is 1. So f composed of g of 0 is just going to be 6 minus 0 squared, which is 6. F composed of g of 1 is going to be 6 minus 1 squared. 1 squared is 1. 6 minus 1 is 5. Now we're going to do the reverse. So it wants us now to go backwards. So do g composed of f of x. I shouldn't say backwards. It's just doing it differently now. So it's going to be g of f of x. So that's going to be wherever you see an x in g, we're going to replace it with the entire f of x function. So here, x is right here. So the x squared. So I'm going to replace this x with x plus 2. So it's going to be 4 minus parentheses x plus 2 squared. So 4 minus x plus 2 times x plus 2. So if I expand that, I'm going to get 4 minus parentheses x squared plus 4x plus 4. Distributing the negative, you're going to get 4 minus x squared minus 4x minus 4, where these cancel. So you're going to get negative x squared minus 4x. G composed of f of 0 is going to be negative 0 squared minus 4 times 0, which is 0. G composed of f of 1 is going to be negative 1 squared minus 4 times 1. 1 squared is 1, so negative 1 minus 4, which is negative 5. Domain. So find the domain of f composed of g for the functions given by f of x is equal to x squared minus 9, and g of x is equal to 9, the square root of 9 minus x squared. So f composed of g of x is f of g of x, which is going to be f of the square root of 9 minus x squared. So wherever you see an x, you're going to replace it with the square root of 9 minus x squared. So it's be equal to parentheses square root of 9 minus x squared minus 9. Radical squared, the square root and the power of 2 cancel. So you get 9 minus x squared minus 9, which is negative x squared. Now, we have to be careful though, because even though this is quadratic, okay, the domain of this is not all real numbers, because the domain of this has to be an overlap of these two. So the only x values that work for this function are, if we graph this, it's going to be between -3 and positive 3. So this actually is a graph that we did in another section. So it's a semicircle. So if you guys graph it in Desmos or on your graphing calculators, it's basically 3, -3, 3. It's a semicircle that looks like this. So the domain of this is just -3 to 3. So basically, even though this is all real numbers, negative infinity to infinity, this is -3 to 3. Okay, we have to take the more strict version of this as our domain of our composition. So the domain of our composition, even though this looks like a quadratic function, is the more strict domain, which is just -3 to 3. Okay, given f of x is 2x plus 3 and g of x is 1/2 times x minus 3, find each composition. So we're going to perform these, and they don't have as much significance to us at this moment, but they will in the future. So f composed of g of x is f of g of x, which means that we're going to do f of 1/2 times x minus 3. So wherever we see an x in f of x, we're going to replace it with the entire g of x function. So this is going to be 2 times 1/2 times x minus 3 plus 3. 2 times 1/2 is 1. So these cancel. So I'm just left with x minus 3 plus 3, which is x. For b, g composed of f of x is g of f of x, which is g of f of x is 2x plus 3. So in my g of x, I'm going to replace every x with the 2x plus 3. So this is going to equal 1/2 times, I'm going to put another parentheses, 2x plus 3. And then the g of x function is also a minus 3. Okay, do the inside first. So plus 3, minus 3. Those cancel. So you're just left with 1/2 times 2x. 1/2 times 2 is 1. So this is just 1x or x. Okay, so here, f composed of g of x equals x, and g composed of f of x is equal to x. So because they equal the same thing, that means that f composed of g of x is equal to g composed of f of x, which is something that is going to be very important in the next section. All right, last example. Write the function h of x is equal to x 1 over x minus 2 squared as a composition of two functions. So basically what we have to do here is we want two functions, f of x and g of x, where if I do f composed of g of x, I'm going to get f of g of x, but I'm going to get, when I'm done, 1 over x minus 2 squared. So we have to think about is for this notation, what that means is f of g of x. So this is the inside function. So if you look, this right here, the x minus 2 is on the inside. So what I can do is I can be clever and say, well, what if I made g of x x minus 2? Okay, so because that means wherever there's an x, an f of x, I'm changing the x to x minus 2. Okay, so I could say that g of x is going to be x minus 2, which means that f of x, okay, if I wanted to change any x to x minus 2, that means the bottom would have to be 1 over x squared. because if I made the x and x minus 2, then it becomes x minus 2 squared, but it had to be just x at the beginning, so that way I can change the x to the entire g of x function. So this is going to be 1 over x squared, which means that I can test this to see if it works. F composed of g of x would be f of g of x. So it'd be f of x minus 2, which means that wherever I see an x in f of x, I'm going to replace it with an x minus 2. And if you see, it's going to be 1 over x minus 2 squared, which is h of x as we wanted. So that means that this is your f of x and this is your g of x. So those are your two functions. And this is the end of 1.5.